Hi and welcome. I'm trying to learn space science. Today Jupiter and Saturn, and after we've done with it, we're going to do standing yoga. And if you participate in the standing yoga, then it's better the Augenlisk. Jupiter and Saturn. In the solar nebula, billions of years ago, there was a strong temperature gradient. Close to the newly forming sun, where it was hottest, icy substances were unable to condense. So it means condense means from gas to liquid or solid. Condensed water. If water gets onto the window, it is called condensed water. It had condensated, so condensed. Okay. Ice could not condense. Okay. While substances such as iron and rock were readily able to do so. Okay, the water could not get icy substance. Okay, let's read on, maybe you understand it a bit better. Okay, it was hot at some place, and the solar nebula, maybe that's the name for the solar system before it was completely born, solar system. Roughly 5 times further from the sun than the present orbit of the Earth, at the so-called snow line, the temperature dropped to a point where ices could condense. Okay, let's read it again. And roughly 5 times further from the sun than the present orbit of the Earth. Okay, there's the sun, and then here's the Earth, and 5 times further away, previously some billion years ago, at that place there was the so-called snow line. The temperature dropped to a point where ices could condense. Okay, they mean probably vapor. Vapor could get firm ice. Let's read on. Icy particles are much stickier than the rocky and metallic ones that condense closer to the sun. Okay, ice sticks better together than rock. And all these rock things were close to the sun, and the further away it was from the sun, the more icy became the materials around there. And so the snow line, I can't read that word, planetesimals, quickly grew to planet-sized dimensions. Okay, there were all of these ice around there, and there was first vapor, I think. But now it was far away from the sun, and there it was cold. At the snow line, there it was cold, and the ice got sticky to actual ice, and it stick together, and it got more together to planetesimals. I think they mean very small planets. But they grew then, more and more snow stick together, like making a snowball bigger and bigger, and then it became then planet-sized dimensions. And in just 100,000 years or so, an icy kernel 15 times more massive than the Earth appeared. Jupiter was forming. Okay. And it took around 100,000 years to form this big ice ball. And it had an icy kernel. And that icy kernel was 15 times more massive than today's Earth. And that was the forming of Jupiter. Okay, I get it so far. There was at the beginning of the solar system, some billion years ago, the forming sun in the middle of the solar center, and it was very warm there. And there could be rocks, but not vapor. That was vaporizing, I don't know. And there were always rocks. And the further away, there could be water, and that water was not so far away from the sun that it was cold, and we got ice. And more ice of stick together, and became a big snowball. And then over the course of 100,000 years, they formed a snowball that big, and with an icy kernel that massive, that this massive kernel of its snowball was 15 times as massive as the Earth, and that's the beginning of the planet Jupiter. By far the most abundant elements in the solar nebula were the gases hydrogen and helium, both light-white, fast-moving and difficult for gravity to snare. Okay, that is complex, and I don't understand it all, but let's look how far we come. Now, by far the most abundant elements in the solar nebula. So we're going to assume now, so we can work on, that solar nebula is the name of a solar system while it was forming. Or that is at least a name for the thing. Solar nebula, we're going to treat it like that so we can go on. Okay, in that time, billions of years ago, the most abundant elements, so the elements which were most rare, were helium and hydrogen. And they are both lightweight. They are helium balloons and they fly up. They are so light, they are lighter than air. Helium is lighter than air. And I'm not completely sure what hydrogen now is. Is hydrogen air? It's a bit more complex. But hydrogen is also very light, and helium is even lighter. and both were very light. And these were the most abundant things. So not rocks were there, or what we have on Earth, a lot of mold, a lot of similar things. We have a lot of iron, a lot of stuff. But there was a lot of helium and hydrogen in that time. And they are both lightweight. They both rise up basically on Earth because they are not pulled back by the gravity much. They're very light. And they were fast moving. Helium, like a helium balloon, it was very light, so it's fast moving, and why not? And difficult for gravity to snare. So I mean, yes, because they had so little mass. Helium is so light, it's lighter than air. A helium balloon flies up because it's lighter than air. And gravity can't really pull a balloon down. A balloon goes up. Now I understand it. A helium balloon, no, let's aside. I think I understand it just. A helium balloon is pulled down to the gravity. Helium is pulled down by the gravity to the Earth, like everything else. But it's just that the air is pulled stronger down. And now we are both having a little battle. Who's pulled down? The helium is pulled down and the air, but the air is stronger pulled down because it's heavier or has more mass, and it's put down and it gets into the first one of a cube. The helium balloon is just pushed down. Now the helium is here, and here's air. Now the book is the helium, and here's now all the air, and the air says, I'm lighter, I want to go down there, and now it goes to the sides down, and the air comes to here, and now logically the helium comes a bit up. So here, at the first place in the curve there is the air, the second place there's our helium, and the third place is the air. The air is heavier and is drawn more to the curve, and it's pulled down and goes here to the second place, and the helium takes the third place in the curve. And that way the helium balloon goes higher and higher up, because it's lighter than the air. It's not so much pulled down. It is pulled down by the gravity, but the air is pulled down more. Okay, and that is why helium balloons rise up. Okay, back to the space science. The icy, newly forming Jupiter grew so massive that its powerful gravity was able to suck in even these lightweight materials. Okay, there was coming a snowball, bigger and bigger and bigger. Now if it is just a little snowball, maybe you've seen it, then it just rolls above the snow and it takes a bit of a snow with it. But if a snowball now gets very big, then it is very big, very heavy, and it presses down onto the ground, and it takes the complete surface of snow with it, and you see the grass again. So a little snowball just rolls over it. But a big snowball takes the whole with it, and then even if it gets bigger, it takes half the grass with it out, and it gets even dirty. It rips half the lawn with it out. And now, this snowball was now getting so big, 15 times as massive as the Earth, that it could pull helium in. Now, the Earth is pulling helium in, but not strong enough. The helium goes away. I heard someone say that there's very little helium on Earth because of that, because the helium goes, I think it was that helium goes away. The Earth seems to have not enough gravitation to pull the helium in. It pulls on it, but it's not strong enough, I think. I think that's it, but I don't know it exactly. But no, in Jupiter it's differently. Jupiter is way, way bigger than Earth. It has much more power to pull things in because it's bigger. And now it was able to pull this helium and hydrogen in. The icy, newly formed Jupiter grew so massive that its powerful gravity was able to suck in even these lightweight materials like helium and hydrogen. For several 100,000 years, Jupiter gorged itself, vacuuming gases from its environment until none were left. Okay, Jupiter grew bigger and bigger and sucked in everything it could get. It had such a great gravity that it could pull in all the helium, and over hundreds of thousands of years it was eating and eating more and more until it was very big. It had sucked in all hydrogen and helium in its vicinity. And it was now 11 times larger than the modern Earth, with a solid core of rock and ice, a gas giant. Okay, Jupiter 11 times bigger than Earth. So Earth is already pretty big, do we have to say? And now Jupiter is 11 times bigger, and in the center there's a rock and ice. And that is so massive that it is able to pull helium and hydrogen in. And helium and hydrogen are gases. They are flying in the air as gas. Now rock is on the ground as a solid, and now gases are flying in the air. And hydrogen and helium are gases, but it has such much power because it's so big, so massive, that it can pull these gases to it, and it is a gas giant. Jupiter is one. Twice as far from the Sun, another gas giant formed, Saturn. Okay, there was Jupiter, and now away from the Sun, even further away, there formed someone else, Saturn. Saturn being further out, where the density of raw materials was much less, Saturn could not grow to the dimensions of its larger cousin. Still, it is a true giant, a respectable 9 times larger than the Earth. Okay, Saturn, I think the same thing happened with Saturn more or less, but there were not so much raw materials. It's just lying more under somewhere else. There weren't so many raw materials, and It didn't grow that big, but it was still 9 times as big as Earth. Gas giants are the largest planets we know of. Jupiter and Saturn are the only two in our solar system. But elsewhere in space, orbiting other stars, these planets are very common indeed. Okay, the solar system has 8 planets. Venus, Mercury, Earth, Mars, Saturn, Jupiter. I have to come through. Jupiter, Saturn, and 2 more. And in the solar system, there are only 2 of these gas planets. Earth is not a gas planet. Earth is a solid rock, and also Mars is a solid rock, and also the other ones are not gas, like Jupiter and Saturn. Okay, in the solar system, there are 2 gases, Jupiter and Saturn. In other solar systems, so there's not just the Sun, but there are other stars, and they have also planets. There are more of them. Okay, I don't have really time. I'm way over time, but that was it now to space science. We will come back to that chapter at some time, repeat it, and when we try to explain to other people in our own little presentation how Jupiter was forming, and the same happened with Saturn. So we will come back to that and read it a little more in detail, but for now I think we have some answers to some questions. Now for now it was it with space science. If you're here for space science, go directly to the next part of space science. We will do now a shortened yoga. If you participate in the yoga, then it is at your own risk. We see the standing together, we're doing the eagle swings. Breathe in the arms up, and breathe out the arms down. You can in the arms up, and out the arms down. Again, in the arms up, and out to the side, release off. In the arms up, and out to the side. In the arms up, and out to one side. Make an inch space between the toes, breathe in the arms up, and breathe out and sink down. Breathe again in, up, and out to one side. Again in, and out and down. Again in and up. Out to one side. Breathe in, up, and out, bring them over the sides, down to the chair. Breathe in, come halfway up, come higher up, and up again. Breathe in, reach high, and breathe out to one side. Breathe in, up, and out and down again. Breathe in, come halfway up, come higher up, and up again. Come up onto tiptoes, and breathe out and sink down into the chair. Breathe in, come up again, on tiptoes, and out and down. And in and up. And out, we're doing the down diving dolphin. We're coming down, feet are standing together. Breathe in and bend the right leg. Breathe out, stretch the left leg for a moment. Breathe in and change. And out and stretch the right leg. In and change. And out, stretch the left leg. And in. And out and stretch the right leg. In. And out into the middle. We're doing the penguin. Breathe in, lift the right hand up to the sky. Breathe out, bend the left knee, look over the right shoulder to the right hand. Breathe in and bring the arm in. And out and down. Breathe in the other hand, the left hand up to the sky. Breathe out, bend the right knee and look over the left shoulder to the left hand. Breathe in and out, arm again down. We're doing the pelican, hand with space between the feet, shift the weight to the heels and breathe in and go down. And breathe out and come up. In and down. And out and up. And the last time down. And out and up. We're doing the triple 6 counterweight. Take hold on the elbows and gently rock from side to side. Feet again together. Breathe again in. Come halfway up. With straight back into monkey half. Breathe out again down. And again in, halfway up. Straight back. And out and down. And now breathe in. The up diving swan. Bring your hands up. And out and down again. The stretch of freedom. Intertwine the fingers behind the back. Legs are standing shoulder width wide apart. Shoulders back. Breathe in. Tall up and breathe out. Bring the head out to one side and the chin down to the clavicle. Breathe again in. And out. Pull the arm in and the shoulder down. Breathe again in. Lift the gaze. Bend the head up to the other side. And breathe out. Bring the chin down to the clavicle. Breathe again in. And out. Pull the arm in and the shoulder down. Breathe again in, lift the gaze, turn the head back into the middle. Now the skyhugger. Breathe in, lift the arms up. And breathe out, lean back, long arms. Again in. And out, lean a second time back. Again in, arms into the middle. And out, lean back, now bended elbows. Again, in the arms up. And out and down, draw shoulder blades together, heart chest to sky. Again, in. And out and down. And we're doing the eagle swings. Breathe in with the arms up. And out and down. Now breathe in, the cactus connecting its stings. Bring the hands to touch and lower the hands down to heart center. That was just standing by. Thank you very much, and until next time.